Good morning, my YouTube viewers. Crystal here. I'm here this morning because I wanted to make a video for you today. I've got my camera turned off because it's the middle of the night and I'm in my nightgown and my hair's a mess and everything else. So I thought it's best to turn the camera off. What I'm going to talk about today is the Titanic. I know we spend a lot of time talking about the Titanic because the Titanic is a very popular data set. It's a very popular data set for beginners. And because it's a popular data set for beginners, it's on the Kaggle website. But I'm using a different data set today. I'm not using the data set from the Kaggle website. I'm using a data set that I found on GitHub. So it doesn't have all of the information this data set doesn't have all of the information that it had on the Kaggle website, but it's the only complete data set that I could find because I wanted to find a data set that was complete. I didn't want one that was split out in train and test files. I wanted the complete file because what we're going to do is we're going to do a data analysis, and because we're going to do a data analysis, then we needed a complete file, and that's the reason why. So we'll go ahead and go with the Titanic data set. I wrote this program on Google Collab, which is a free Jupyter notebook. It's a great program to use because if you use Google Collab, you don't have to install any software, any programming software on your own computer. I had a netbook and my netbook malfunctioned, and I had Linux and Python installed on my netbook. But then I discovered Google Colab and I stopped using Google Colab. And because my netbook, sorry, it was a Chromebook, because my Chromebook malfunctioned, I had to get another laptop, and I did not even install any programming software on my new laptop. I just used Google Colab. So it's a great program to use because you don't have to install any software on your computer, and you can just get directly to the business of programming, which is what I like to do. I like programming and solving problems and writing blog posts, and this will be a blog post as well. So if you want to get the code for this video, then you need to read the blog post. So first thing we're going to do is we're going to read the problem statement from Kaggle. It says, the sinking of the Titanic is one of the most infamous shipwrecks in history. On April 15th, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in the death of 1,502 out of 2,224 passengers and crew. While there was some element of luck in surviving, it seems some groups of people were more likely to survive than others. In this challenge, we ask you to build a predictive model that answers the question, what sorts of people were more likely to survive, using passenger data, i.e. name, age, gender, socioeconomic class, etc. Well, the first thing about this Titanic data set is on Kaggle, they say that they want you to build a model that's going to predict what type of people are going to survive. But actually, the only thing that you did was you created a data frame of the survivors, and then you submitted the data frame of the survivors to Kaggle. So that's not really answering the question that they ask. So I thought, well, what we'll do here is we'll go ahead and answer the question that they ask. Now, the thing that really surprises me is the data set that I have is 1,309 rows. But you had 2,224 passengers and crew. So that means that it wasn't complete. The data set wasn't complete. I would need to go through the train and the test file and check out the SIB spouse and the parent child, and then count up everybody from SIB spouse and parent child on the train and the test file. But that doesn't tell you how many people survived. That just tells you how many people were actually on the Titanic. So the chart that I have is 1,309, which is pretty close to the data set that you have from Kaggle, because the data set that you have from Kaggle, you had 981 and then 418. So I can't get my calculator out. Let me just see. I've got my little tablet. I can't use my calculator because I don't have any light in my kitchen, because the light blue and the housing cooperative has said that they're not going to do any repairs during a pandemic. So it said that's 399. I thought it was 9. This data set is, let's just see what it is. It's 1,309. So let's try this again. I think it was 891 plus 418 equals 1,309. So what they did was they took the original Kaggle train data set of 891, and then they added it to the test data set of 418 to make it 1,309. So the data set is complete. The data set is actually complete, except for the fact that what I need to do is I need to go through the original train data set and the test data set, and then I need to count how many are on the families and the SIB spouse, because it should, if the data set is correct, it should equal 2,224, but that's not what we get on this data set. We get 1,309. So that is another anomaly, and so that's something that I'll have to check out. I'll have to go back and check in the train data set and the test data set and see how many people are actually on that manifest. That's one thing I'll do before I make my blog post. So it's a good thing that I'm doing this code review, because when I do the code review, I can find out things that I didn't do, or maybe mistakes that I made, or things that I would like to do. So that's one thing I would like to do, is look at the train and the test file and determine how many people were on SIB spouse and how many people were on parent child, and then that will tell me how many actual passengers there were. So the first thing we do is, because getting back to the program, the first thing that we're going to do is we're going to import the libraries. And so because the libraries are already installed, you don't have to install them. You only have to import them. So just to start out, just as a precursory measure, we're going to install Pandas, NumPy, Matplotlib, and Seaborn. So that's the first thing that we imported, that were already installed on the system. And then what we're going to do is we're going to load and read the files. Well, I found this file on someone's GitHub account, and his GitHub account had been made public, so I borrowed his file. And it was 1,309 rows by 7 columns. And basically, it doesn't have all of the columns that the data set in the Kaggle has, i.e. it doesn't have the name of the people, it doesn't have where they embarked from, it doesn't have whether they were a parent-child or whether they were a family. And that's one thing I'm going to go look. I'm going to count how many people were parent-child and how many people were family to find out how many people were on that manifest, because it's not really clear. If there were 2,229 people on the boat, then in theory, you would have 2,229 rows, or failing that, you would have people on the sib spouse and the parent-child to actually indicate that there were 2,229 people, and obviously we don't have that on this data set, so that's something that needs to be looked into. So we have described the data set, so you can see the count, the mean, and the standard deviation, min, 25%, 50%, 75%, and max. So that tells you a little bit about this data set. You can look at the info, ID, P class, and survive are integers, and sex, age, HB, and fair are objects. So because on the age and the fair were separated by commas, they were not separated by decimals, they were separated by commas. What I had to do was I had to use code to replace the commas with full stops to actually make the value work. I don't know why he put a comma in there. I think perhaps he was from a different country where they use commas instead of full stops, but I don't know. So what we wanted to do is the age and the fair, after we had replaced the commas with full stops, we converted those to floats. So the age and the fair are now floats instead of strings, which is what they were previously. And what we want to do is we want to check for any null characters. And in age, we had 263 null characters. In fair, there was 1 null character. So again, that's something that needs to be looked at. So what we wanted to do was we wanted to fill all the null characters with 0. So in age and fair, any null characters were 0. And you can see right here, there's a 0 here. We check again for any null characters, and you see we still have 263 and 1 null characters, so that still needs to be imputed. We check the info of the file, so ID, P class, and survive are integers, sex is an object, age is float, HB is an object, and fair is a float. So now what we do is we need to go through the process of imputing some of these null values. So this is a code I got off of Stack Overflow. So if HB is an adult, then you're going to replace the null value with the median age of the person. And if HB is a child, then you're going to replace the median age with 9. Because I thought, well, a child is from 0 to 18, although we're not sure exactly what they considered a child in 1912. But I'm just going on the assumption that child is from 0 to 18. So 9 is half of that. So if they were a child and the age was left blank, then what I did was I just said they were 9 years old. And if they were an adult and the age was blank, then they were just given the median age. So then what we did is we checked is null again. So all of the ages had been imputed for. So now we just have to impute the fair. So data fair equals data fair fill in a median. So we're just replacing the fair with a median value. And then so now what we're doing is we're checking is null. We're checking for null characters. And now we don't have any more null characters. But I see we've got a warning. It said output cache limit hit. It says currently 1,000 entries. So I don't know why it did that, but it did. Now what we're going to do is we're going to perform an analysis on this data set, which is what the purpose of this video is for. So there were 809 passengers who survived and 809 passengers who died and 500 who survived. So that means 62% of the passengers died and 38% of the passengers survived. And here you can see a graphical representation that the survivors were less than the people who died. Let's go back here. It says right here, about 1,502 people died out of 2,224. So let's just look at my calculator. So that says 2224 minus 1502 equals 722. So it means that 72 people actually survived. But on this data set that we have here, it says 500 people survived. So that means we're missing 222 people. So that means this is not a complete data set. But of course, we already knew it wasn't a complete data set. We're missing 200 and how many people we said survived. How many people did we say survived? 222 survivors. So it's not a complete data set. It's too bad that it isn't. So now we're going to look at the sex of the people on the Titanic. So you had 466 females and 843 males. So you had more males than females. The females were 36% and the males were 64%. So it was almost 1/3 females and 2/3 males. And you can see a graphical representation of that. Now we'll look at the passenger class. You had 3 classes. So first class was 323, second class was 277, and third class was 709. And then so you can see that 25% was first class, 21% was second class, and 54% was third class. So, and then you can see a graphical representation of that as well. So now what this data set did is it determined whether the person was an adult or a child. So you had 1,200 adults and 109 children. So 92% of the people on board were adults and 8% were children. You can see a graphical representation of that. Now we'll look at the age. I plotted a violin chart of the age. And so you can see what the ages were on the boat by looking at the violin chart. So the maximum age was 80. The minimum age was a newborn. The median age was 28. And the most frequent age was 28. And so I think it's because I had to do that imputing. And I said impute all null values. If they were an adult, impute all null values with 28. So I think that's why you got 28 as being the median age. So now we're going to check out the fair. And again, what we've done is we plotted a violin chart of the fair. And so most of the fairs were not that much money, because you've got to remember this was over 100 years ago. So the maximum fare was £512. The minimum fare was 0. The median fare was $14.45, and the most used fare, most frequent fare, was $8.05. So I've got a little chart here for you that just shows you the survivors against the people who perished. So if it's green, it's a survivor, and if it's red, it's someone who died. And so you can see up here we've got a few outliers up here as well. And that's just a nice little chart, nice little scatter plot, just to give you an idea of the survivors against the people who didn't survive. Now what we want to do is we want to filter out the survivors, because what we want to do is we want to create a data frame of just the survivors. So this new data frame is called survive. So we want to check the sex of the sex of the survivors. So females were 339 and males were 161. So females were 68%, and males were 32%. So even though the ratio of people on the boat was 1/3 females to 2/3 males, of the survivors, the ratio is 2/3 females to 1/3 male. So proportionally, more women passengers survived than men. About 2/3 of the survivors were women as opposed to men. So now we're going to look at the passenger class. So of these survivors, one was in first class was 200, second class was 119, and third class was 181. So let's go back here and see how many first class tickets there actually were. There were 323 first class tickets, and of those first class tickets, 200 survived. So more first class tickets survived than, proportionally more first class tickets survived. So you had 323, 277, 709. I'll try to remember that. And that's what they said. They said if you were rich, then you were more likely to survive. So that's pretty much what happened. They gave priority to the people in first class. And so 119 were second class, and they had 200 and something in second class. So first and second class, they had less tickets, but they had a higher proportion of people in first and second class that survived than they did third class. So they had like 181 were third class out of, I think it was 700 and something third class tickets. So that means that the people in first and second class were given priority over the third class tickets. So if you were third class, you weren't given a lifeboat. You were just left to fend for yourself. And most of the people didn't fend for themselves. 1,000, over 1,500 people died. So that wasn't very good. That was just a typical example of how badly poor people get treated. And you can see how it's represented in this data set that poor people get treated. And then whenever I do my blog posts, I'll be sure and compare. I'll be sure and write a comparison saying, well, of the so many first class tickets available, 200 survived, which is a percentage of such and such. And then I will go ahead and give the percentage of survivors, which I'm not doing here on this code review because I'm just talking ad lib. I'm sure, as you can tell, I'm talking ad lib. But when I write the blog posts, it will be a lot more accurate, which I'll say I get more views on my blog posts than I do my videos. But I hope that you're getting something out of the video. So you can see, but that's what we're going to do. So 40% were first class, 24% were second class, and 36% were third class. But that's not an accurate representation because you need to actually compare that with the number of tickets that were on the manifest. And then when you compare the number of first class survivors to the number of tickets, and the same with the second and the third class, then you will see that the people in third class, they got the bad deal. They were just left to fend for themselves, whereas they gave votes to the first class and the second class, but not the third class. It's just another typical example of how poor people are treated in our society, that they just let the poor people die. So now what we're going to do is we're going to look at the survivors, whether they were an adult or a child. So there were 439 adults and 61 children. So I believe that it was really over 100 children on the manifest. So you have a higher percentage of children who survived than adults, because they would say, oh well, women and children first. So they let the women and children go on the boats, the lifeboats, before the men would go on the lifeboats. So men were just really at the mercy of the weather, really, or at the mercy of the seas. So you can see a percentage of that. So there's something wrong with this because it says age B and it said percentage, it said adult was 240%. So that's not right. That's not right at all. So it says survived percentage equals age B over Lynn survived times 100. So it's exactly the same type of code. It's the survived P class. Oh, I can see where I made a mistake. I said it was, instead of saying survived age B, I said age B, so I made a mistake there. So that is something that I'm going to need to go through and correct. So that's another good reason for me to go through these code reviews, because I can find out mistakes that I made before I do the actual blog post. So that's something I'll have to go through and correct when I finish this blog post. So now what we're going to do is we're going to check the survived age, and I'll put the survived age on a violin chart. So you can see that the median age was around 30. So you can see the maximum age was 80. The minimum age was 0. Median age was 28, and the most frequently used age was 28. And that was to do with the fact that if the age was 0 and it was an adult, then I just said we'll put the median age there. So that's why that was the most frequently used age as well. So now we're going to look at the fair. And I did a violin chart on the fair, so you can see that the most of the fares were between 0 and 50. So we'll say that the maximum fare was 512, the minimum fare was 0, the median fare was 26, and the most frequently used fare was 26 as well. So now what we want to do is we want to ordinal encode our categorical columns. So what we did was we mapped male and female, and to give male 1 and female 2, and then we mapped that into the sex column, and we mapped whether they were an adult or a child, and we mapped that into the age column. So that was mapped. I decided to do that rather than to do ordinal encoding, and the reason why is because I don't know, sometimes I want to sort of get away from using sklearn, because sklearn is a good library, but it takes a lot of the thought process out. And the thing is, it's like when you use ordinal encoding with sklearn, you don't necessarily know what the numbers are going to be, but if you map it, then you can decide what the numbers are going to be. And then I decided that what I was going to do is I was going to convert the age to an integer. And the reason why I wanted to convert the age to an integer was because I just felt, well, it'll be easier for the computer to work, the computer program to work, if it's just having to deal with integers instead of floats. And I think that I converted the fare to an integer as well. So the age and fare were converted to integers because I thought, well, it's not going to make that much difference. Just if you just filter the age out for a specific year or the fare out for a specific pound amount, it's not going to make that much difference. So that's why I did it, and I thought it will be easier for the program to work if it's integers. So now what I've done is I've set up my X and my Y values. So Y is data survived. Features is P class, sex, age, HB, and fare. And X is data features. Now what I've done is I've made a 2D graph of all this. And I'm using PCA, principal. It's called PCA. I don't remember what it's called, principal component analysis. So we had to put X on a standard scalar. I had previously tried to normalize X, and then when I tried to normalize X, it didn't work. So this 2D graph is like an sklearn formula, an sklearn model. So I had to put standard scalar on it, but previously I didn't have standard scalar on it. I just normalized it myself. We get the mean and the standard deviation, and then we define the feature columns, so 0 to 4, and then we normalize the feature columns. Okay, and then so now what we've done is we've used the coding to get the 2D graph, and so you can see that the survivors must be purple because you had less survivors than you did people who perished. So I just thought it'd be nice to put a little 2D graph in there so you can see, you can compare the survivors against the people who died. And so the survivors are actually mixed in there with the people who died. And that's one of the things that makes it more difficult for this algorithm to work. So now after you've seen your 2D graphing, you can get a representation of what the data looks like in the CPU. Then what we're doing is we're splitting the training file up for training and testing. And I use train test split for this because train test split has a lot of neat stuff to it. So we set the test size up to 10%, shuffle equals true, random state equals 1, and stratify equals yes. So when you're dealing with a classification, you need to set stratify up for yes, because what it does is what it attempts to do is to address any class imbalances. So now we're going to select our model. I decided to use a neural network in this situation, so I used LPC classifier, had 50 hidden layers. I had activation as logistics because it was the binary solution. Solver was Atom. I originally tried LBFGS, but I got a convergence error on that, so I couldn't use that. I just could use Atom. Random state equals 1, max iterations equals 500, and verbose equals true. I like to set verbose up to true so I can see it working, because especially when you have a big data set and it's just churning away, you don't know what it's doing if the verbose is turned off. But if you set verbose to true, then you can see what it's doing, and it'll give you a little bit of reassurance that the computer program is actually working. So we had, when we trained and fitted our model, we had a 79% accuracy. And then what we did was we predicted on the validation set, and we had an 82% accuracy when we predicted on the validation set, which was a higher accuracy than I would have received on the Kaggle data sets where you had a train file and a test file. So what we've done is we created a confusion matrix. So in the confusion matrix, you had of the zeros, that's the people who died. You had 69 were correct and 12 were incorrect. And of the ones, that's people who survived, you had 38 that were correct and 12 that were incorrect. And that's in your confusion matrix. And then what we did was we developed a data frame of the actual against the predicted, so you can compare the actual values against the predicted values if you want to. So now what we're going to do is we're going to plot the errors. So I'm just going to say that the purple is the correct ones and the yellow is the incorrect ones, because you didn't have that many incorrect answers. So that's your errors. That tells you what your errors were. So that concludes this video of an analysis. So I performed an analysis based upon the data set that I have been given, and I also put it on a model and with a neural network to go ahead and solve it anyway. So I hope you like this video. This data set is a little bit different from the previous data sets that I've worked with, because in the past I've been working with Kaggle data sets. So I hope you found this beneficial, this analysis beneficial, and I will be making a blog post and I will be analyzing the results, because I think that the way that it had been done in the past, where you were just looking at the passengers, but you also need to look at the survivors as well and compare the survived statistics to the passenger statistics, and then you will get a lot more insight. For instance, we found out just still looking at this analysis that if you were in the first class or the second class, you were more likely to survive than if you were in the third class. So that's something very interesting. So this concludes my presentation. If you like my presentation, please like, subscribe, and share. If you want to receive notification of whenever I make a video, then please press the bell button to the right of the subscribe button, and you will receive a notification whenever I make a video. And if you like the work I do and you want to support me, I've got my email address to my PayPal account in the description box down below. And I don't have enough subscribers, so I have to ask for donations. So thank you so much again for watching this video, and I look forward to making new videos for you in the future.